Alright guys, let's integrate the trig functions. So here are our rules. Okay, some of you, of course, we've been doing these. But be careful, because right here, two other rules that can be developed. We have tangent and cotangent. Because as you can see up here, we don't have an integral of tangent or an integral of cotangent. So we actually have to rewrite it before we use it. So what happens when we rewrite it? Well, the integral of tangent is also the same thing as saying the integral of sine x over cosine x dx, which we know that if I set u to cosine x, du would be negative sine x. So really when we look at this, we're looking at the integral of 1 over u du, and it's going to be a negative because we have that negative there, right? I should say dx here. And what is the integral of 1 over u is ln. So we get negative ln. Now when we take the integral and we get ln, it's absolute value, and our u is cosine x. There are no boundaries, so we need to have our plus c. That goes the same thing as here. We have cotangent is cosine over sine dx. U would be the sine x, and du would be cosine x dx, leaving us 1 over u, right? And then the integral of 1 over u is ln. Don't forget the absolute value. In this case, u is sine x, then plus c. Alright, so knowing that proof there, we have some other things that we can keep in mind. Now guys, don't forget you can be making your note cards to memorize these. So let's do some of these questions together. The integral of negative 3 sine x. Well, that negative 3 can be pulled out front, and that stays there, right? So, negative 3, the integral of sine is negative cosine, but of course, when we do this out, those two negatives cancel, so we get 3 cosine x plus c. For 4, for 4, what we need to keep in mind is that we have kind of a chain rule here. So if we do u is pi t, then du is pi dt. Okay, solve for dt, you get dt equals 1 over pi du. Okay, so that means we have a 1 over pi out front. So what we're looking at is 1 over pi integral cosine u du, which equals 1 over pi sine. And now instead of u, I'm going to put the pi t plus c. Alright, number 5, if we do u as in y cubed, that would mean du equals 3y squared dx. Solve for du, you get dx equals du over 3y squared. that cancels this y squared out, so we have 1/3 integral of secant squared u du, which is a rule right here, guys. So the answer is tangent, well, 1/3 tangent of y cubed plus c. Okay. In this one, if I look at the u as 2x plus 1, du is 2 dx, so dx equals du over 2. That leaves us with 1/2 out front, secant u tangent u du, and if you look at your rules, that is number 5 up here. So that equals 1/2 secant. Instead of u, I'm going to put that back in as 2x plus 1 plus c. Okay. Number 7. Let's see what we can do with this. Number 7, it looks like we want our u right here. So let's do u is sine of 5x. So du would be cosine, well, 5 cosine, because the derivative of the inside there, cosine 5x dx. Okay, solve for that. We would get dx equals du all over 5 cosine 5x. The cosine 5x cancels right here. So if you look, we would get, and I'm going to write it right over here so I have room, we have 1/5 the integral of u squared du. Alright, so when we look at that, oh, and by the way, I wrote that wrong, right? It should be 1 over. Alright, so then we know that this is 1/5 integral of u to the negative 2 du, which equals 1/5. I'm going to write my u's back in, guys. So we have sine to the negative 1 of 5x. Now don't forget we have to divide by the exponent. So if we divide by a negative, it becomes a negative plus c. Okay, now this means that sine would be in the denominator, right? So another answer that could happen here is negative 1/5 cosecant 5x. Okay, because this is negative 1. Alright, number 8. Let's look at this. If you see, there is a connection, because if we made u equals tangent, you would get du is secant squared. Hopefully you start recognize those derivatives that are in there. D theta. What happens is these two cancel, right? So I get 1 over u du, which we know equals ln absolute value. Now I'm going to put that u back in there. So tangent theta plus c. Alright guys, a couple more here. Alright guys, so here we're going to integrate tangent squared. But if you look at all your rules, we don't have anything with tangent squared. So what we actually have to do is rewrite it. Now the other day we talked about the Pythagorean identity. The one that we would use the most is sine squared x plus cosine squared x equals 1. Well, there's a couple more, and it looks like we are going to have to know these two. So because we don't have a rule for tangent squared x, what we're going to do is rewrite it. And we can rewrite it as secant squared x minus 1 dx. So from here. Now we can actually take those integrals separately. So the integral of secant squared is tangent x. The integral of 1 is x. And then at the very end we need a plus c. Alright, in this next one we're going to need to find the area. So you need your calculators, guys. You're going to go to y equals and plug in those equations. Make sure that your calculator is in radians. Then let's change the window because we also have a boundary of 0. And let's see. I think y is fine. So let's just go from there. Alright, there's that cosine. And there's the tangent. So guys, as you can see right here, we're from here to here. So from 1, let's see, it looks like 2, and then it goes down, and it passes through, and then we have something where it is up. So we're shading right in there. As you can see, I can set this a little bit better. So let's go to, oh, that's not what I want. Let's go, actually we could, max going, it's pi over 2, so pi divided by 2, graph, it's a little bit better. And then we see where it intersects, right guys? Right there. So I'm going to go second trace, intersect, go close to it, 1, 2, 3. So the intersection, don't forget to go 3 decimal places, is at 1.082. Alright, so all we're doing is setting this up, guys. So we have from 0 to 1.082. It's the area bounded. So of course, remember, it's top minus the bottom. So the top one is our cosine. So 2 cosine x minus 1/2 tangent x dx. Now we're going to use our calculator to actually integrate that. So let's go back to the main page. And then math, go all the way down to integral. We're going from 0 to 1.082. We have 2 cosine x. Nope. Minus, be careful of your parentheses, guys, 1/2 tangent x. Okay, like I said, be careful of those parentheses. We're in dx. So our answer is 1.388. And we are done.